Good evening. I'm Steve May with the Federal Aviation Administration. Tonight we will provide an update on the Southern California airspace modernization, more specifically the Southern California Metroplex. I am joined by Rob Henry, Southern California Metroplex Project Manager, and Jose Gonzalez, Southern California Metroplex NATCA Co-Lead. The airports we will be focusing on tonight will include Los Angeles, Burbank, Camarillo, Point Mugu, Santa Barbara, and Van Nuys airports. The procedures that will be implemented on the March 2nd and April 27th chart publication dates will be our focus for tonight's presentation. Fundamental to meeting the overall next-gen air traffic management, there has been and still is the need to evolve air traffic to a time-based system. An aircraft must be capable of receiving dynamic and complex instructions from ground systems that identify where they need to be and at what time. This requires the FAA to implement digital communications, leverage advanced navigation performance and flight management systems, and design and implement new airspace procedures. Once NextGen is fully implemented, we will be able to identify the location of each airport at any point in time along the way to its destination. This will have a tremendous impact on our ability to manage air traffic more safely and efficiently. Looking at the Southern California Metroplex study area, the study area covers a large portion of Southern California from Santa Barbara to Palm Springs and down to San Diego. It includes 6 major airports, including Bob Hope Airport, Los Angeles International Airport, Long Beach Airport, Ontario International Airport, San Diego International Airport, and John Wayne Orange County Airport. There are also 15 satellite airports within the study area. The goals of the Southern California Metroplex include improving flexibility and predictability of air traffic routes through increased use of performance-based navigation. The improvements will be achieved by utilizing satellite technology and publishing and implementing advanced procedures. Tonight we will look at several procedures, including area navigation, abbreviated as RNAV, standard terminal arrivals, abbreviated as STARS, standard instrument departures, abbreviated as SIDS, required navigation performance approach procedures, abbreviated as RMP, optimized profile descent, abbreviated as OPD. Area navigation is a method of navigation that mitigates the limitations of an aircraft navigating from one ground-based navigational aid to a satellite system providing point-to-point operational capabilities. Standard terminal arrival route is a specific, repeatable path with lateral and often vertical descent guidance for arrivals to an airport. Standard instrument departure is a specific, repeatable path with lateral and often vertical climb guidance for departures from an airport. Required navigation performance, or RNP approach, is an approach providing a higher level of precision than an approach using ground-based navigation. And finally, optimized profile descent is a procedure that keeps arrival aircraft at cruise altitude as long as possible before beginning an uninterrupted descent. Once begun, the procedure departs from the usual pattern of stair-step descent all the way down to landing. We took a phased approach to executing the Southern California Metroplex project. We started out with the study team phase, which completed in December 2011. This phase included potential opportunities and operational issues were identified to determine if a benefit could be developed through the application of performance-based navigation procedures and airspace changes. These designs were highly conceptual. The next phase was the design team phase and was completed in March 2014. This phase was used to refine the study team recommendations and conceptual designs into final, implementable, performance-based navigation procedures and airspace designs. The next phase was the evaluation phase and was completed in August 2016. With this phase, the proposed procedures were evaluated to determine if they met operational, environmental, and safety requirements. And the final phase is the implementation phase, which began on August 31st, 2016, and is currently ongoing. After issuance of a finding of no significant impact, record of decision, activities in this phase are to complete and execute the implementation of the procedures developed during the previous phases.
Good evening, I'm Rob Henry, SoCal Manager, Metroplex Manager. Let's begin our procedure discussion with departure and landing direction, or runway in use. Wind direction and velocity are key factors used to determine departure and landing direction. Wind speed below 5 knots is negligible. Runways are typically identified by their runway magnetic heading. Example, west flow for runway at San Diego International is 275 degrees magnetic. The last digit is dropped and it becomes San Diego runway 27. The rationale for operating into a headwind is simple. The more wind flowing over the wing provides more lift at lower ground speeds. A tailwind makes aircraft faster across the ground, requiring more runway length. Southern California airports typically experience westerly winds which favor west operations. Two terms you're going to hear a lot when we talk about satellite-based routes are optimized profile descents and optimized climb profile. Here's how they work. First, the optimized profile descent. Please notice the dotted blue line. This represents current flight operations. A traditional descent is like walking down a flight of stairs. Based on air traffic code instructions, the pilot descends and applies speed brakes, then levels off and powers the engines up, then descends and applies the speed brakes again. The cycle repeats itself until the plane is on its final approach to an airport. Please note the solid blue line. It represents the optimal profile descent. By contrast, an optimized profile descent has built-in speed and altitude restrictions at various points on the route. These restrictions are designed to provide automatic separation from aircraft on other routes by either vertical altitude separation or lateral distance separation. This information is programmed into the airplane's flight computers and allows the aircraft to glide down to an airport at near idle power, and controllers no longer have to issue instructions after clearing the plane to begin its descent. OPD are safer in that there is less pilot-controller interaction. Airplanes flying OPDs versus traditional descent generate less noise and emit less pollution because the engines are at near idle and speed brake use is minimized. Please note the yellow area on the chart. The yellow area depicts a dispersed vectoring area. Current arrival procedures utilize ground-based navigation and radar vectors. Controller vectoring creates high workload for air traffic control and flight crews. Vectoring creates inconsistent flight paths and creates a wide dispersion area of arriving traffic. Vectoring also provides for inconsistent vertical profiles as altitudes are assigned by air traffic control. Arrival procedures do not connect to the approach. The next slide is an RNAV RNP example, or the RNAV required navigational performance. In this example, note arrival route 1 and arrival route 2 are fictitious stars that are connected to the required navigational approach. RNAV stars connect to the RNAV procedure. The stars and approach connectivity provides for a repeatable and predictable flight path. The RNAV simplifies operations for flight crews and air traffic. It allows the use of flight deck automation, and the RNP provides a stabilized and efficient approach operation. The optimized climb profile example. Please note the dotted blue line. A traditional climb profile is like walking up a flight of stairs. Based on air traffic instruction, the pilot climbs and then levels off and powers the engines up and then climbs again. The cycle repeats itself until the plane is at final cruise altitude. Note the solid blue line. By contrast, an optimized climb profile has built-in speed and altitude requirements at various points along the route. These restrictions are designed to provide automatic separation from aircraft on other routes. This information is programmed in the airplane's flight computers and allows them to climb at optimal power, and the controllers do not have to issue instructions after clearing the plane to climb. An optimized climb profile is much more efficient than traditional climbs and is a key benefit that we are seeing today from our use of satellite-based routes. Optimized climbs are safer due to less pilot-controller interaction. Aircraft flying optimized climb profiles versus a traditional climb generate less noise and emit less pollution. Summary of our benefits: reduced air traffic control task complexity, reduced communications between the flight deck and air traffic control, reduced phraseology, reduced frequency congestion, reduced pilot workload, repeatable and predictable flight paths, accurate fuel planning, and laterally or vertically separated flows.
Let's take a look at the National Environmental Policy Act. The Southern California environmental assessment process began with study team participation in November of 2011. The draft environmental assessment was released on June 10, 2015, and the public comment period was open for 120 days. The finding of no significant impact record of decision was signed on August 31, 2016. The final environmental assessment is available on the Southern California Metroplex website. We will provide the website information to you towards the end of this briefing. The finding of no significant impact record of decision enables the agency to move forward with replacing dozens of existing conventional air traffic control procedures with new satellite-based procedures. The FAA began phasing in the use of the procedures starting in November 2016 and continuing through April 2017. When the Southern California Metroplex procedures are implemented, some people might see aircraft where they did not previously fly. This is because some air route changes will occur, and because satellite-based procedures create more concentrated flight paths than conventional procedures. Some people will experience noise decreases or increases, and some will experience no changes at all. Some flight track dispersion will continue to occur after the new procedures are implemented because the Metroplex project includes a number of existing procedures. Also, air traffic controllers will need to occasionally vector aircraft for safety or efficiency reasons or to reroute them around weather systems. The following noise maps are created to enhance the understanding of all potential noise changes in the study area. Please note that many of these changes occur at noise levels at or below the noise level experienced in everyday living situations in the area. The noise maps represent noise changes of DNL plus or minus 1 decibel. For many people, the small change is difficult to distinguish. The FAA DNL metric is a value representing the aircraft's sound level over a 24-hour period and includes all of the sound energy generated within that period. The DNL metric includes a 10 decibel weighting for noise events occurring between 10 p.m. and 7 a.m., which we considered as nighttime noise events. The FAA did not use these maps for decision purposes. Noise maps are provided for disclosure purposes only. This next slide looks at increase and decrease in DNL at or above DNL 45 A-weighted decibels, or dBA. In the map, you will see a blue shaded area. This represents the DNL decrease. You will also see a green shaded area, which represents the DNL increase. The bold line around the Southern California area is the general study area boundary, and the smaller lightly shaded polygons are the community or city boundaries. The 45 and above decibel noise level map is provided based on FAA's established criteria for changes in noise levels. This next map looks at the increase and decrease in DNL at or below DNL 45 dBA. Once again, the blue denotes the DNL decrease and the green denotes the DNL increase. And again, you will see the general study area boundary, the communities and cities within the general study area. Although there is no established FAA criteria for changes below 45 decibels, this map displays those changes to enhance the understanding of all potential noise impacts in the study area and is provided for informational purposes only.
Next, we'll discuss community engagement. Southern California community engagement began with early notification of the draft EA January 21st, 2014. The FAA conducted 11 public workshops from June 16th through July 1st, 2015. We held the workshops in Santa Ana, Santa Monica, Los Angeles, San Diego, Palm Springs, Torrance, Long Beach, Ontario, Ventura, Santa Barbara, and Burbank. The FAA extended the public comment period for a total of 120 days, with public comments ending October 8, 2015. Approximately 4,000 individual comments were received. Approximately 2,700 unique comments and or form letters were received. Approximately 380 comments were received after the public comment period closed. However, these comments were included in the draft environmental assessment. Approximately 570 comments were received from 3 online community groups. Responses to the comments are included in the environmental assessment. Based on community comments, the FAA reviewed all procedures. Our analysis consisted of reviewing the following: safety. What we considered under safety: will the change have an adverse impact on safe operations? The team considered aviation safety information analysis and sharing data with potential impact to airspace, procedures, and enhancement of safety. We looked at traffic collision avoidance system hotspots, terrain avoidance warning system alerts, high energy descent and approach events. Next, we looked at efficiency, and we considered, will a change or recommendation create substantial inefficiencies? Finally, we looked at complexity. Will a change increase workload beyond a reasonable level for controllers and flight crews? Next, we'll look at March 2nd and April 27th, 2017 procedure implementation. This chart depicts the procedures that will be implemented for Los Angeles, Burbank, Camarillo, Point Mugu, Santa Barbara, and Van Nuys procedures with the implementation date of March 2nd, 2017. The next procedure again will show the implementation for Los Angeles, Burbank, Camarillo, Point Mugu, Santa Barbara, and Van Nuys with an implementation date of April 27, 2017. Let's begin looking at procedures for Bob Hope, Van Nuys, and Santa Monica Airport. Before I begin with Burbank, I wanted to take a second and look at the chart itself. First, let's look at the inset in the upper right corner. This depicts 1 day of arrival traffic to Burbank and Van Nuys, dictated by the blue lines to the airport. Next, you'll notice the orange line, which indicates the star. The yellow area depicts the environmental assessment area. Moving to the larger portion of the map, you'll notice again the orange line depicting the star. Along the star, you'll see the arrow that indicates the name of the star. In this situation is the rocker star. Coming down the star, you'll notice the first satellite-based waypoint. It is indicated as a white star. The waypoint is identified by its name, again with the altitude that correlates to that waypoint. In this situation, the waypoint name is Rocker, and the altitude window is from 11,000 feet to 12,000 feet. Continuing down the star, there are several transitions to the airport. Continuing down to the Van Nuys Burbank Airport, the light blue or green line depicts the transition or the approach to the airport. The Rocker 1 star to Burbank ties into the new Burbank Runway 8 required navigational approach. It follows the historical tracks of the Burbank Simi star. It maintains lateral separation before leading to vertical separation from the Los Angeles Ironman star. The OPD is less than optimal due to interactions with the Los Angeles Ironman star. The Burbank, Santa Monica, Van Nuys Throne 1 star. There are no current published procedures for Burbank, Santa Monica, and Van Nuys arrivals from the east. The Throne 1 serves Burbank, Santa Monica, and Van Nuys airports. The design segregates these aircraft from Los Angeles, Hollywood, Angel Stars, and arrivals. It's deconflicted from the Long Beach, Orange County Disney, and the Ruby Stars at lower altitudes. The next slide is a Burbank SID. It's the Burbank Aros and the Burbank SLAP SID. To clarify on this slide, you will see the environmental area evaluated in magenta. Again, you have the inset of showing 1 day's worth of traffic, and again, showing the departure in magenta with the name indicated on the arrow. The Aros 1 serves jet departures to the northwest. The separation of departure flows from Burbank and Van Nuys will allow aircraft to proceed on course sooner. The SLAP 1 SID serves jet departures to the northeast and southeast and is deconflicted from overflight traffic on Victor 459 airway. The aircraft on the Burbank Janney and Ontario Galarno stars are also deconflicted. So additionally, it's laterally separated from the Burbank, Van Nuys, and Vera SID. Provides more optimized lateral tracks. The Burbank Van Nuys Vera 1 is a prop SID. The prop departures, it serves prop departures to the northeast. It serves all Burbank runways and Van Nuys runway 3-4. It's laterally separated for the Burbank SLAP and Van Nuys Harry SIDs, reducing complexity and interactions with Burbank Van Nuys jet departures to the northeast. The Van Nuys Harrys, the Van Nuys Roscoe, and the Van Nuys Rocker 1 SIDs. The Harry's 1 SID serves runway 16 jet departures routed to the east. It provides segregated routing after SLAP for Van Nuys prop and jet departures. It reduces complexity based on separate jet procedures for Burbank and Van Nuys departures. The Roscoe 1 SID serves runway 16 prop departures for the northeast. It's laterally separated from the Burbank SLAP and the Van Nuys Harry SIDs, reducing complexity and interactions with the Burbank Van Nuys jet departures to the northeast. The Walker 1 SID serves runway 16 jet departures routed to the north. Current procedures rely on ground-based navigation aids. The Los Angeles and Santa Monica Airport procedures. The Los Angeles and Santa Monica Boget 1 Star. The current Chemo Star is a conventional procedure relying on ground-based navigation. The Boget Star will replace this procedure with RNAV capability. It serves turboprop aircraft landing Los Angeles and all aircraft landing Santa Monica from the east. It is deconflicted from the Long Beach, Ontario, Palm Springs, and Orange County arrivals. Additionally, it is deconflicted from Burbank, Los Angeles, Ontario, Santa Monica, and Van Nuys departures. The Los Angeles Angel 1 and the Hollywood 1 RNAV Stars. Current Los Angeles arrivals, River and Seaview Stars create a bottleneck for arrivals and are responsible for the heaviest volume into the Metroplex area. The Stars connect to the Los Angeles RNP approaches for runway 24 left and right and runway 25 left and right. The Angel and Hollywood Stars are optimized profile descent procedures. Additionally, an offset approach option was designed to Los Angeles South Complex was created. The Los Angeles Sunset 1 Star. The current Oldie Star is a conventional procedure relying on ground-based navigation, utilized by aircraft landing Los Angeles from the south after leaving Mexican airspace. The new RNAV Star is deconflicted from the Orange County Piggin SID departures. It ties into the Los Angeles RNP approaches to runway 24 left and right and runway 25 left and right at Seaview. The Los Angeles OLAS Star is an RNAV Star. It serves arrivals from the south. It connects to the Los Angeles approaches for runway 24 left and 25 right. It is designed to more closely follow historical tracks and was moved offshore away from populated areas as long as possible. The Los Angeles Goats and the Ontario Carl B Stars. The Goats 1 serves Los Angeles arrivals from the southwest. It allows aircraft to be as much as 7,000 feet higher over Santa Catalina. The routing will be unavailable when military airspace control extension C1177 is active. It is deconflicted from Orange County Hero SID, and it ties into the new Los Angeles RNP approaches at Tornado. The Carl B1, currently there are no published arrival procedures to Ontario for aircraft from the west. Carl B1 allows aircraft to be as much as 7,000 feet higher over Catalina. The OP design impacted by interactions with Los Angeles and Orange County departures, as well as San Diego and Palomar arrivals. The Los Angeles Rider 1 is a name change from the Crusher 1, the Los Angeles Hull, and the Ironman. The Rider, Hull, and Ironman Stars all follow the same lateral path after based and will tie into the new RNAV RNP approaches for Los Angeles. Cliffy is co-located with Santa Monica altitudes. Cliffy is co-located with Santa Monica BUR. The altitudes allow aircraft to be up to 1,000 feet higher than the current procedures. Current ILS approach procedures allow aircraft to be descended immediately after passing Santa Monica. For aircraft flying the RNAV RNP approach, the altitude restriction at Dodger provides a minimum altitude of 6,000 feet until approximately 5 miles east of Santa Monica. The ILS approach is still available for non-RNP equipped aircraft. When requested, visual approaches will continue to be assigned when traffic conditions allow. The Los Angeles RNP Zulu for runway 24 left and right, and the RNP Zulu for runway 25 left and right. The stars connect to Los Angeles RNP approaches. The RNP approaches will provide a more repeatable and predictable path, increasing efficiency and safety for the Los Angeles arrivals. The Clipper offset transition will act as an offload, routing to be assigned by air traffic control only on a dynamic basis for aircraft arriving Los Angeles from the east. Weather conditions that exist in Los Angeles can limit the use of visual separation. The offset transition to Los Angeles runway 25 left and right approach can be assigned by air traffic to maintain lateral separation between the north and south complexes without the need to stagger arrivals to get below the mid-level ceiling or weather that limits visual approaches. Current ILS, localizer, and GPS approaches were amended to provide continuity with new Metroplex designs. The Los Angeles Big Bear and Bruin stars were designed to replace the best star. The Big Bear and Bruin stars follow the same lateral path as the Angel and Hollywood stars to the downwind transitions at higher altitudes due to longer flying distance to the west of LAX. The Big Bear and Bruin stars are laterally separated and will provide independent flows for Los Angeles east flow operations. The Los Angeles Zuma 1 star serves Los Angeles arrivals from the north when landing to the east. The Walker intersection was relocated offshore with an altitude restriction of at or above 6,000 feet. The Zuma 1 star provides OPD benefits when Los Angeles is landing east. The Zuma 1 is deconflicted from the Long Beach Pacific, Orange County OC, the Burbank and Van Nuys Rocker stars. It connects to the Los Angeles RNP approaches for runway 6 left and right and runway 7 left and right. Additionally, the Zuma 1 star ties into the Santa Monica RNAV GPS Zulu. The approach, which maintains procedural separation from Los Angeles arrivals when LAX is landing east. Additionally, it ties into the Santa Monica Runway 2 RNAV GPS Zulu approach, which maintains procedural separation from Los Angeles east when Los Angeles is landing east. The Los Angeles Midnight Star, the Metroplex team considered community input and developed the Midnight Star to replace the Red Eye Star for midnight operations to 6 a.m. local time, arrivals to land Los Angeles on the eastbound runways. The current Red Eye Star requires aircraft to cross Santa Monica at 8,000 feet and routes aircraft towards Malibu. There are no vertical restrictions on the Red Eye Star west of Santa Monica. The new Midnight Star contains a vertical restriction of 8,000 to 10,000 feet over a new waypoint, Clippy, co-located with the Santa Monica BUR, and a second restriction of 7,000 feet, a new waypoint, Sassy, created over the ocean. After crossing the shoreline, the lateral track remains over the ocean and away from Malibu. The Los Angeles Lady J RNAV SID is an RNAV off the ground. Its vertical restrictions deconflict the Los Angeles Rider, Ironman, and Hull stars. TCAS alerts between aircraft departing Los Angeles and aircraft arriving from the northwest are expected to decrease. The Orca 1 RNAV SID off Los Angeles is an off-the-ground SID that replaces conventional Los Angeles Loop SID. Departures performing a climbing left turn back over Los Angeles Airport. Vertical restrictions at Clipper ensure aircraft comply with the existing noise abatement procedure and deconflict from arrival traffic. Multiple en route transitions allow air traffic controllers greater flexibility depending on the status of military airspace. The Los Angeles DOTS and Panda 1 RNAV SIDs. The DOTS replaces the Holt SID. It allows for more unrestricted climbs while allowing an OPD on the San Diego Comic Star. Lateral tracks were designed in conjunction with the Ontario Raji, the Orange County Piggin, the Long Beach Fritter, and the Santa Monica PV SIDs. The Panda 1 replaces the Carver SID. It is designed to deconflict from the Palomar and San Diego arrivals, and 2 transitions were added for greater flexibility. The Los Angeles Moose 1 prop-only RNAV SID is for props-only departures west and northwest from Los Angeles. It's deconflicted from the Los Angeles jet arrivals and departures. Initial navigation is radar vectors. The Los Angeles Dark 1 and Triton 1. The Dark 1 serves departures to the west and routed to the southwest, west, and northwest. It's deconflicted from Los Angeles, Long Beach, and Orange County arrivals. It's designed to route aircraft away from military restricted airspace, R2519, and warning area 289. Provides more direct routing for oceanic traffic and earlier diversion of traffic flows to the San Francisco Bay Area and the Pacific Northwest. The Triton 1 departure serves departures to the east and routed to the southwest and west and northwest. It's deconflicted from the Long Beach Pacific and the Orange County OC Stars, designed to route aircraft away from military airspace, restricted airspace 2519. It also provides earlier diversion of traffic flows to the San Francisco Bay Area and the Pacific Northwest. The Los Angeles Windy 1 RNAV SID serves departures to the east that are routed to the northwest. It's deconflicted from Burbank and Van Nuys departures and provides earlier diversion of traffic flows to San Francisco Bay and the Pacific Northwest. The Los Angeles Gardy 1 and Tusty 1 SIDs. The Gardy 1 serves Los Angeles departures on eastbound runways. It requires aggressive climb gradient due to terrain. Aircraft unable to maintain 420 feet per nautical mile climb will be assigned the Los Angeles Tusty SID. Altitude restrictions added to the procedure to deconflict from the Ontario Sunshine SID, the Ontario Galarno Star, the Los Angeles Big Bear, and Bruin Stars. Currently, air traffic controllers are required to vector aircraft off of Los Angeles in the current configuration. Tusty 1 serves Los Angeles departures on eastbound runways to the east and southeast. It's laterally separated from military airspace, restricted area 2503 Bravo and 2503 Charlie. It's designed to provide RNAV departure procedures for Los Angeles traffic departing on eastbound runways who are unable to maintain the Gardy climb gradient of 420 feet per nautical mile. The Santa Barbara Municipal Airport, the Mission 2 RNAV SID. The Mission 2 is for current eastbound procedures utilizing radar vectors. It's designed as an RNAV off the ground. Concurrence of design was achieved with the airport operator, pilot crew, air traffic control in this noise-sensitive area.
General project information. This briefing is for informational purposes and does not reopen the Southern California Metroplex environmental. Any noise issues should be directed to the appropriate airport noise office. Information about the Southern California Metroplex project is available on the Metroplex website. This presentation will be available online. Additional public information. Before publishing the procedures, the agency is conducting public information meetings and webinars to further inform people about the changes. The FAA will notify the public through press releases and on Facebook, Twitter, Instagram, the Metroplex website, and possibly other additional platforms. The currently scheduled community engagement is highlighted in the following table. Note that this presentation is one of the 4 listed internet-based webinars, and that in the following weeks, we will conduct a total of 10 community informational briefings. Please refer to the Southern California website for times, locations, and content for each of the community informational briefings. And now for the Southern California Metroplex website information. The first link indicates the Southern California Metroplex Environmental Assessment website. This is the main web page for the website, and all other web pages can be found by navigating to this page. For specific information, we noted the frequently asked questions and the various environmental assessment documents and the Google Earth files. Additionally, the final environmental assessment, Appendix F, contains the FAA responses to public comment. Due to the large size of this appendix, it was broken down into 3 files. Each of the 3 volumes is available on the website using the following URLs. Once again, this presentation will be made available on the website. This concludes our formal presentation, and we will now move to the questions and answer portion of tonight's webinar.
Steve, we had a couple questions come in. The first one is, and it was a statement to start with, this is good information. However, where can I get more specific information on the procedures? More information can be found at the FAA website. The FAA is also providing 10 public workshops starting next week throughout different communities in Southern California. At the workshops, FAA subject matter experts will be available to explain the procedures in depth and answer all the questions.
All right, thanks, Rob. The next question is the FAA taking into consideration comments that I may have, and if so, how do I submit them? A public comment period was provided during the draft environmental assessment phase of the project in the summer of 2015. The FAA evaluated and responded to more than 4,000 public comments received during the 120-day public comment period, and the final environmental assessment was issued August of 2016. These comments and all project documents can be found on the Southern California Metroplex project website at metroplexenvironmental.com.
Steve, another question came in, and it was, how can I find out more information about noise in my neighborhood? Well, first, the EA website has detailed instructions on how the person can determine the noise changes on Google Earth. The second way is the public is invited to our workshops where we'll have an environmental station, and the subject matter experts will be there and available to help them look at the noise in their community. The next question was, how will possible changes in the configuration of Burbank Airport change these procedures? And I think we're asking about the direction of landing or departing, meaning configuration. The configuration does not change with the implementation of SoCal Metroplex procedures.
All right, the next question, have these new routes already been implemented? Some procedures were implemented in November, but all of the procedures that we've discussed this evening will be implemented on either March 2nd or April 27th of this year.
The next question that came in is, will there be more webinars prior to the April 27th implementation? Currently, there are no plans for further meetings other than those that are listed on the webinar and the workshops. However, these briefings will be posted, and the individual could review them at their leisure on the website.
All right, here's another question. Are you increasing capacity at Burbank Airport? The FAA does not determine capacity or flight schedules at any of the airports.
Thanks, Steve. And the last question that came in was, does the rocker star change how aircraft arrive into Burbank? The rocker star is an RNAV procedure that will provide a repeatable and predictable flight path into the Burbank, thereby enhancing flight safety. The track of the rocker star remains within current flight tracks. That was the last question we had come in, Steve.
All right. Well, I want to thank Rob and Jose for their help tonight. This will conclude our webinar presentation for the meeting. And we thank you all for joining in and making the Southern California Metroplex project a success.